Have you ever really stopped to think about what holds reality together? Like fundamentally, what makes things solid, coherent?
It's a deep question.
Right. Well, today we're going to dive into something called Fox Coherence Density, or FCD for short. And our goal here is really to unpack it, to see how FCD offers this new lens on the energetic cost of just being, of maintaining structure, information, from tiny particles right up to, well, us.
It's fascinating stuff. At its core, FCD is about measuring how densely and how coherently an information state packs its local spacetime value signature.
Okay, let's break that down a bit. Information state.
Think of it as the unique blueprint, the dynamic pattern of anything that exists, whether it's a subatomic particle or, a complex thought.
And the local spacetime value signature.
That's how that specific blueprint imprints itself onto reality right here, right now, how it holds its form within spacetime. So FCD basically quantifies the energy needed to keep reality organized at that point, to maintain stability.
Okay, stability. And the unit for this is joules per meter to the 6th power, JM6. That sounds intense.
It does, yeah. Joules, that's energy. That makes sense. The M6, meters to the 6th, that's the part that usually makes people pause.
Right. How do we even picture that? Volume is meters cubed, M3. Where does the extra M3 come from?
Well, think of it like this. One M3 is the volume, the space it occupies. The second M3 conceptually represents the quality or the integrity of the information within that volume.
Like how crisp its definition is.
Exactly. How coherently packed its information is, preventing it from just fuzzing out. It's the energy cost to define and sustain that stable state, its distinctness.
And FCD isn't linear, right? It's logarithmic.
Crucially, yes, logarithmic. We're talking values from maybe 1030 for like potential unrealized mass, stuff that barely exists.
Wow.
All the way up to 106, maybe higher for everyday macroscopic objects.
So the difference between just potential and something actually stable is astronomically expensive, energetically speaking.
Hugely expensive. The universe pays a massive premium for coherence and stability. It's not a cheap process.
Which leads us to how complexity actually builds up, right?
Yeah.
The FCD emergence equation.
Precisely. And this is key. When things combine to form something new and more complex, the FCD of the new entity isn't just the sum of the FCDs of its parts. That would be too simple.
Okay, so not just adding FCDs together, what happens then?
You actually multiply the FCDs of the individual components, and then you multiply that result by another factor, a coherence factor, which we call C.
Multiply and add another multiplier, the coherence factor, CF.
Exactly. And this CF is always greater than 1. It's a unitless number that represents the extra energy investment needed.
Extra energy for what?
To lock in the new, stable information state. This covers the energy for its emergent properties, things the parts didn't have alone, like, wetness emerging from H2O molecule.
Right. No single water molecule is wet.
Correct. It also covers the increased complexity, the internal entanglement between the parts, and something we term relational gravity.
Relational gravity, not like physical gravity.
No, think of it as the intrinsic energetic pull that binds these different informational pieces into one single cohesive system. It's the cost of creating that unified whole with new properties. Forming coherence always costs more energy.
Okay, let's make this concrete. Walk us through building, say, a human using FCD. How did that cost ladder up?
All right, so you start at the absolute base level, a fundamental unit. Its FCD is basically a function of its inherent energy, its spin, its volumetric information footprint. Let's call it K times those properties.
Okay, basic unit FCD. Then an atom.
Right. To form an atom, you take the FCDs of all its constituent fundamental units, multiply them together.
Multiply them.
And then multiply that by an atomic coherence factor, CF atom. The CF pays for the new stability, the atomic bonds, the emergent properties of that specific atom.
Makes sense. And then for a molecule like water, H2O.
Same principle, just scaled up. You take the FCD of one hydrogen atom, multiply by the FCD of the other hydrogen atom, multiply by the FCD of the oxygen atom.
So FCDH times FCDH times FCDO.
Exactly. And then multiply that product by a new, generally larger molecular coherence factor, CfH2O. This accounts for the energy needed for its specific structure, its polarity, hydrogen bonding, all the things that make water, its unique molecular stability.
Okay, I see the pattern. Atoms to molecules.
Yeah.
Next step. A biological cell. That's a huge jump in complexity.
Massive jump. For a cell, you'd conceptually multiply the FCDs of literally trillions of molecules, proteins, lipids, DNA, water, everything.
Wow.
And then apply an absolutely enormous coherence factor.
Right.
This CF cell represents the staggering energy cost to create and maintain a living, self-regulating, dynamic system. It's off the charts compared to a simple molecule.
Right. The energy cost of life itself, basically.
In a way, yes, the cost of that level of organized coherence.
And finally, the human, the culmination.
Culmination. You'd multiply the FCDs of every single cell plus all the other bits, trillions upon trillions, and then apply the ultimate coherence factor, CF human.
Which must be unimaginable.
Pretty much. This final immense CF accounts for everything. All our emergent properties, consciousness, thoughts, memories, emotions, our sense of self, our constantly changing information state. It bundles the energetic cost of our entire being. The final FCD value for a human is, well, it's profoundly large.
So FCD gives us a framework, almost like an equation, to predict the energetic price tag for complexity and stability, starting from almost nothing.
That's the idea, a way to quantify the energetic investment needed to build stable reality from an informational blueprint.
It's really a powerful way to think about, well, everything. The sheer energetic effort baked into the structure of the universe, from the tiniest quantum flicker right up to our own consciousness.
It certainly shifts perspective, and it leaves us with a pretty significant thought, doesn't it?
Much is.
If we truly understand this energetic cost of coherence, what does that imply? What might it mean for our future ability to, say, influence or even create stability, to engineer matter, or perhaps even new forms of stable information from the ground up?
Controlling the very fabric of coherence. That's definitely something to think about.